Good morning, Vietnam.
Okay, Unit 3. We will start talking about bivariate data. What does bivariate mean? Two variables. So we're going to make some scatter plots in this unit. We will make some time series plots. We're also going to use the acronym LSD in this unit. So,
I'm advocating for some simple things, and I'd like to complain.
So,
Suspension.
suppose we found the age and weight for each person in a sample of 10 adults. Is there any relationship between the age and weight of these adults? That's what we want to find out. So, what I want you to do in your calculator is I want you to put age in your list 1, and I want you to put weight in list 2.
Stat.
So, from here, my list 1, we're calling our age, and list 2, we're calling weight. So, it's bivariate because when you think about it, you're asking one person 2 questions. That's how we know something is bivariate versus something that's univariate with 2 different groups. So, an example of univariate 2 groups could be I'm asking males and females their age. I'm only asking them 1 question. This I'm asking one person 2 questions. The 2 types of graphs that we can make is a scatter plot and a time series plot. However, we can't make a time series with this because our x-axis must be time. So we can create a scatter plot from this. In order to make a scatter plot, I'm going to go to second, y equals,
Plot 1.
and I'm going to turn plot 1 on, or it should already be on. And then the type is this first little scatter plot. It's the first one.
X-list.
Where x-list is L1, my y-list should be L2. So you hit that second 2.
What about Mark?
From here, mark doesn't matter. Zoom 9.
How do you? Whoa. Good grief, there is no correlation.
Wait, did you say Zoom?
It's the top, like almost the top right button, but the second from the right.
Whoa, I thought you were talking about
So looking at this, does this have any correlation?
No. It looks like my marching band.
No correlation. It looks really weak.
Yeah, agreed.
Why do you think that is? Because what are the age ranges from here, if you're looking?
24 to 50.
24 to 50. So they're all adults, right?
Roughly.
They're all pretty much adults. So there really isn't a correlation between adult ages and weight. But if I were to maybe change the age ranges, where do you think you could find a correlation? Children. So maybe if I started at 1 and I went to 18, there could probably be some sort of positive correlation if I were changing the ages. So that is how you make a scatter plot. I want to also take this data, since we have it pulled up, and I want to show you another thing we'll learn using the calculator in this unit, and then I will explain it more so later. But the second calculator thing that we will be using is calculating a least squares regression line, or a line of best fit. But we don't say line of best fit because that's for babies. So if you want to calculate the line of best fit, but I'm going to call it the LSRL, I'm going to hit stat, calc, and then I'm going to go down to option 8, linear regression. I'm not going to use option 4, and like if you can see the differences, 4 is AX plus B, and then 8 is A plus BX. In statistics, we typically write the y-intercept first, and we call that A. We write the slope second, and we call that B. So you can use option 4, but it switches the variables, and sometimes it gets a little confusing. Whoa, I don't know why it went all the way down. Oh, there. Okay. Gonna keep X list, Y list. You can keep the other things blank. Store regression equation. If I wanted to actually plot the line and compare it to my scatter plot, you could put Y1 in there, but you don't necessarily need to, and I'll never make you do that. So now it gives you your line of best fit, or your least squares regression line. So I would write this as y hat, and the hat means predicted y, equals 198.739. Let's go out 3 decimal places. Minus 0.764x, where y hat represents what? Predicted weight. And my x represents age. If I ever ask you to report the line of best fit or my LSRL, you'll want the actual equation, you'll want the hat, and you'll want to define your variables. Does anyone in their calculator have r and r squared below that?
No. I do not. Yes. No, man. Oh.
They should be there, and the reason why they're not there is because your stat diagnostics are not on. So anytime you clear the memory, the stat diagnostics get turned off. So to turn them on, they must be turned on. You need to go to mode and scroll all the way down to stat diagnostics. Right above stat wizards. I've never found out what stat wizards are, but
It's on though.
Stat wizards are on. Don't turn them off. I don't know what that means.
Apparently, it's according to my clock, it is January 9th, 2001 at 12 a.m.
Search it up, Keller. Search it up and like.
So second quit.
2001. I wasn't alive. It's 2001. You weren't. Negative.
Now we try stat calc 8 again.
You weren't.
2005.
And now you should have r squared and r.
Got it.
I'm going to label what these are right now, and then we're going to talk about them as the lesson progresses. But I want you to just know what. So A is going to be my y-intercept. B is my slope.
It's deviation.
It's also technically negative, so that means that it has a negative correlation. My slope and my r should always be the same sign. R is going to be my correlation.
Wait. They should be
The same sign,
R and R squared?
but not r squared. B and r. Like my slope and my correlation should be the same sign. Correlation tells me my strength, like how strong is the correlation. And then r squared is called the coefficient of determination, which we will talk about in a minute. Determination. I had to split it into 2. So these are the only 4 things that your calculator will give you that we learn in this chapter, and also making a scatter plot. So you have learned the calculator portion. That is exciting. Okay, so now we decided to change the x-axis or the variable to be height and weight. There is definitely much more of a correlation between height and weight than there is age and weight for adults. So this would be a positive correlation. Do you think that it is weak or strong? Just looking at, it looks pretty strong. And I'm going to give you a way to how you can mathematically decide whether it's weak or strong. So correlation can be positive or negative, and it can be weak or strong, or if it's in the middle, we call it moderate. And there are certain number points in which we decide that. What does it mean if a relationship is positive?
It's good.
It's good, but
It's going up.
as your x is increasing, what happens to y? Y increases. For negative, as x increases, good. Can anyone think of an example of something that might have a negative correlation in everyday life?
Days of school that go by and how much sleep I get.
So the more days of school that you have, the less sleep you get, the further into the year.
That is correct. The amount of education
You just give up. Yeah, senioritis kicks in for everyone around 4th grade.
What about like the
Fourth credits.
the more minutes of exercise you get a day, the lower your cholesterol or something like that.
The higher your miles per hour, the less gas mileage you get.
That's not.
No, that doesn't work.
The more,
You can say the less gas you have in your tank.
yeah, the more miles that you drive, the less amount of gas in your tank.
Exponentially.
Those are good.
Oh, a negative one. Teamwork. The more days we go without an unnamed record, the fewer mistakes we make.
I will say that there will be conceptual questions that we all love. You know how we had to decide whether something was right or left skewed or symmetrical? There will be scenarios in which you have to decide, is it a positive or negative correlation? I think these are a little bit easier though. Yes.
And Larry in any piece and scenario.
No. Okay, identify strength and direction. 4A.
Positive.
Positive.
Strong.
Strong. Good. B.
No correlation.
None.
State that point because
C.
Negative. Weak. Negative.
Negative, weak. We might call it moderate. D.
Positive. Strong.
Positive, strong, but it is curved. We're going to talk about what that means in a minute. Identify as having positive, negative, or no relationship. Heights of mothers and heights of their adult daughters.
No relationship.
Yes.
There's genetics in there.
Positive.
Like the taller their mother, the taller their daughter. That's the way we're seeing it. Age of car in years and its current value.
Negative. 4 years.
The older the car, the less it's worth. Weight of a person and calories consumed.
Positive.
Good.
Positive.
Whoa, I gave you the answer. I'm sorry.
No correlation.
Height of a person and the person's birth month.
No.
Is birth month even able to be put on a scatter plot?
No.
It's categorical. What are they thinking?
1 through 12.
What if you do months starting with January? So like
truly
Does it make sense to average those, Karen? Does it make sense to average?
Average number of months away from January, that makes sense.
yes, it's like a standard deviation.
It
Not
literally is a standard deviation.
Number of hours spent in safety training and the number of accidents that occur. Negative. It should be negative. So, correlation coefficient.
HR training. No correlation.
In ourself.
Correlation coefficient. This is where, when we describe the correlation coefficient, or when we comment on a scatter plot, we look at the strength, direction, and linear relationship between X and Y. So this is the acronym LSD, and I put L first because it makes sense, even though when you're saying it, you might say that it is strength, direction, and then linear. But LSD stands for linear, strength, direction. So when you're commenting on the correlation coefficient in a scatter plot, you will say there is a linear, strong, positive. So this is linear, this is strength, this is direction, relationship between X and Y. So between height and weight. So I will ask you to write a sentence script commenting on the correlation coefficient between the two variables. So you'll have to type in the data into your calculator, identify the correlation coefficient, and then comment on that using this script. If you want to say strong, positive, and then linear, I sometimes write linear last because it seems to make more sense in my head. But if you want to memorize LSD, then linear goes first. It doesn't matter. Any of these are interchangeable. Pearson's sample correlation is used the most. That's just the letter R. Population correlation coefficient is rho. Remember Greek and English. The English alphabet. Greek would be rho, which would be for population, and then sample is going to be R. we hardly ever find the population correlation coefficient. Now, this is the formal equation for finding the correlation coefficient. I am not going to ever make you memorize this. However, I'm going to erase this just for a second. And I'm just going to throw this out there. What does this equation look similar to? Something that we've already learned. The z-score.
Yes.
Because it's value minus mean over standard. So it's finding the z-score for x, and it's finding the z-score for y. It's multiplying those together and adding them up for every value in your scatter plot. Yes?
Wait, so do you have like a strong correlation the higher the number is?
You have a strong correlation the closer that the points are together into forming a linear function.
So like your R. Like on the last one.
Well, we'll talk about the numerical values of r in a second. Okay? So let's go ahead and get some more practice. I want you to put the expenditures in list 1 and graduation rates in list 2. When you're making a scatter plot, everyone look here and listen. You do not need any numbers when you make a scatter plot. All that you need are the x and y axes to be labeled. And you need the dots in the correct places, relatively. When you're making a scatter plot, the only thing that matters is the relationship between the points. The numbers or the scales do not matter, and we'll get into why in a minute. We are just looking at the relationship between the points. So, to make a scatter plot on the AP exam, on a free response, label the axes, draw the dots. Okay? They need to look very similar to what you see on your picture. From here, if you did Stat Calc 8, linear regression, you should get an R value or a correlation coefficient of 0.05. Now, based on your picture, what kind of relationship does it look like? No correlation. It has to be exactly 0 to have no correlation. It's not exactly 0, but it is 0.05. So it is positive, but it is very, very weak. So I'm going to say there is a weak, positive, linear. Yes, relationship. You always have to use the word linear.
Do we have to use relationship?
Relationship. You can say correlation
So
between.
you just put linear and you can get points because it can never be non-linear.
It can be nonlinear, but I'll show you why later.
Curves.
Between expenditures and graduation rates. So what the R is telling me is the linear relationship. So that is why I say linear. Later on, we can see if maybe a linear relationship isn't the best option. But what R is describing is the linear relationship.
Oh, and this is what the actual value is.
So when your R value is equal to 0, it is no correlation. If it is between negative 0.5 and positive 0.5, we consider that to be a weak correlation. Moderate is anywhere from negative 0.8 to negative 0.5, or positive 0.85 to positive 0.8. And then strong is anywhere from 0.8 to 1.
Will it ever be above 1, or do you know you did something wrong if it is?
It'll never be above 1. 1 is like a perfect correlation. So an example of that would be you took a sample of 10 couples where the wife was exactly 2 years younger than the husband. So if you plotted the ages of both of them, they would make a perfect correlation. And that, like if you had 1, then that would mean that every single dot goes through your LSRL, or your line of best fit. So if you could draw a line, it would go through every single point. That would be a perfect correlation. That was a good question. This is the script that you will use. We already talked about that. LSD. So linear strength direction. That is to describe R. You must state X and Y in context. Now, suppose that the graduation rates were changed from percents to decimals. So I'm going to change all of my 64.6 to 0.646. My 53% to 0.53. So go ahead in your L2 and change all of these from percents to just proportions. Divide by 100. Yeah. You could go to L3 and then divide by 100. L2 divided by 100.
Okay, it's an error.
You just get the R.
So your R is what?
The exact.
Oh my gosh, this is almost as fun as Statland.
Oh, I got a
Yes, that
I got 0.06.
You go to L. You can go to L3, highlight it, and say L2 divided by 100.
I got 0.06.
You did it wrong.
Luna, what do you mean by that?
So when I divided all of my points by 100, that did not change my correlation. So multiplying and dividing all points does not change your correlation, because your correlation coefficient R is the relationship between the points. So the scale does not matter. That's why I said don't even put numbers on your scatter plots. Scale does not matter.
So even if it's multiplied.
Even if if I multiplied them all by 100. If I'm doing something to all of them, like all of my x's or all of my y's, or both, my scatter or my R value does not change.
So is that with adding and subtracting?
Same thing. So even if I did these transformations, I'm not going to make you do them, but if I changed all of my x's to be 5, or if I added 14 and multiplied by 5, or if I added 30 divided by 4, any of those, adding, subtracting, multiplying, dividing, if I'm doing it to all of the values, not just one value, but all of them, it does not matter. So we say that the value of R is not changed by a linear transformation. That means I'm going to write add, subtract, multiply, divide.
So it's resistant.
No, that's not funny. Now, if I wanted to switch X and Y, so what I want you to do is I want you to go to Stat, Calc 8, and I want you to make your X list L2, and I want you to make your Y list L1. So you're flipping your X and Y axis. That's fine. It's the same. What? No way. That's the coolest thing I've ever heard.
That's like crazy.
I don't think I could have survived.
The stat wizards are doing this for you.
Magic box. No C calls it. Get out your magic box.
So, R does not depend on which of the two variables is labeled X. So you could switch the two and still get the answer correct in some form or fashion. The line of best fit will change. So if this were a free response and you didn't know which one was X and which one was Y, you would get partial credit for having the correct R value, but you would get the line of best fit wrong. LSRL. Should be unfortunate. Now, suppose that I change this 33.6 33.9 to 63.9. So I'm just changing 1 point. So go back into L2, delete the 33.9, and add in 63.9, and find R. This might be a little disappointing.
Oh no.
It changes.
Maybe. I don't want to give it away.
I mean, it kind of should.
No.
It can't.
Don't cry.
The stat wizard's gone.
But it changed in a good way, right?
No!
Yes! It went up. Change is good.
No, it's not.
It didn't change in a good way.
It did. It went higher.
It was way up.
It's still a weak.
Wrong.
I will say that the value of R is affected by extreme values, so that means that it is not resistant.
See, the other one was resistant.
The median is resistant. The IQR is resistant. R is not resistant.
Because it doesn't have
don't
the
like that.
IQ to do that.
Okay, I get it. It is not resistant.
You need to add. You need to
Can't say I had to scoot up.
die. I can't.
Okay, what I want you to do,
Put up with this anymore.
So-
I'm confused.
your scatter plot should look something like this. But my R value is 0, so does that mean that there is no relationship?
No, it means
No.
there's no correlation.
It means that there is no linear relationship. Because R tells me the linear relationship, but there clearly is a relationship.
It's called a parabolic.
Quadratic.
It's called a quadratic relationship.
Look at how it's
Jesus talks about this. I swear.
But since my R value is 0, that means that there's no linear relationship. Okay? So value of R is a measure of the extent to which X and Y are linearly related. So here are all of the properties. You do need to highlight this slide, memorize it, tattoo it on your arm, something like that.
already have long
So, do you give us permission?
I already have way too many
Miss
tattoos.
T just said it was okay that we get a tattoo.
Maybe like a henna tattoo or something.
If
If I can tattoo this in my arm,
The most important concept in this chapter, and if you use this word, this evil word, you will be killing a puppy. This is
Another killing a puppy.
yes.
You make a puppy cry.
No, you will actually kill the puppy if you use this word. This word right here, causes, is evil. Because do I say, like if I have a perfect correlation,
Evil.
do I say that one causes the other to happen? No, you don't. You don't.
respond to reality, man.
I will say, here
not a cause.
Here are funny examples that are actually statistically proven from studies done that have a very high correlation, like 0.99, 0.98. So the relationship between the number of cavities in child's teeth and the size of his or her vocabulary is strong and positive. So does that mean that the more cavities you have causes you to have a higher vocabulary?
I think it's the other way around.
Using those long words, they just exhaust me.
Because you talk so
Are you
much.
serious?
And so
But the relationship is strong and positive.
I think it's just coincidental though, because
So does that mean I should feed children more candy? Why do you think that that's true though? Like what is the reason behind that probably?
They talk so much.
No.
Your mouth just gets so tired from all those long words.
The older you get, the more cavities you're likely to have as opposed to being younger. And so that's probably why, because
I think
it's more of an age and a higher vocabulary than number of cavities.
Ice.
I'm not so sure about
So they're both related to age.
Misleading.
Okay, the next one is weird. Consumption of hot chocolate is negatively correlated with crime rate.
Drink all the hot
People stay inside in the
Have you ever seen a thug drink hot chocolate?
So let's all drink hot chocolate to lower the crime rate. That's what we need to do.
I think Rebecca's the most committed
It
person.
warms
in
your
this
heart.
class.
I'm on your side.
That's probably because it's cold outside and no one wants to do any crime when it's
Or
cold.
it's because thugs don't drink hot chocolate.
You shower again. All that happens is all my problem.
So,
hot chocolate, that means
listen when I say this. Do not say that one causes the other to happen. And later on in the next chapter, cause will be an okay word to use when we have a well-controlled, well-designed experiment. But we haven't even learned experiments yet. So we cannot use the word cause. So say it with me. Correlation does not imply causation. Correlation does not imply causation. One more time. Correlation does not imply causation.